Alrighty, so let's begin with 2D collisions conservation method. This is completely a return to the idea of vectors. Okay, so we're going back in time. Two masses are moving before a collision is shown. We have a 3 kilogram mass moving at 4 meters per second north, and a 2 kilogram one moving at 5 meters per second at north 45 west. After collision, mass B is observed to be moving at 3.5 meters per second at north 20 east. Find the velocity of mass A. That's a lot of words and a lot of numbers, right? Let's start by drawing a picture. Now, how much space? Do you guys have probably space on the right-hand side there? So that's where I'm going to draw it too. So before, we've got mass A moving north, like so, and I think I need to... Okay, so mass A is moving north at 4 meters per second, like so. And B is moving at 5 meters per second at north 45 west. So B, I'm going to put in a different color just to make it a little more clear for you guys. It's moving at north 45 west like this. Okay, so maybe two curling rocks, although two are very rarely ever going at the same time like that. Where are these two going to go? Just sort of your gut tells you what A is going to go, kind of forward and to the left, and B is going to go kind of forward and to the right, right? And in fact, after the collision, B is observed to be moving at 3.5 at north 20 east. So after, this is the after, B is going, this is B, make it a bit bigger, at north 20 east. So it's going like this. So which direction is A going to be going? It's going to kind of be going something like that, right? Ish, as you kids like to say. Okay. Is the initial momentum equal to the final momentum? Yes. So let's start with sort of just that structural thing. Initial is equal to final, just to get our thinking involved. And then can you say, would you agree then that the initial x is equal to the initial y? So that's not what I meant. The final x, that's what I meant to say. The sum of all the x components initially is equal to the sum of all the x components after. And likewise, the initial y is equal to the final y. So we're going to basically kind of break it down almost, if you want, into two sort of separate collisions. The x collision and the y collision. Okay? So we need to find, let's just deal with x first of all. We need to find the x component of all of the ones that we know, right? Okay, so ax right here, what's the x component of A to begin with? 0. That's why I started with that one, because it's easy. Right? Because the A is only going straight ahead north. Why? Okay, good. What is the bx before? Well, we've got this triangle here. And that angle is north 45, right? So the bx is this one here. That's adjacent. So it's going to be something cos 45. What is that something? What is this hypotenuse? Well, it tells me that b is moving at 3.5, but that's only the velocity. I also need the mass, right? So it's... No, this is the initial one here. Oh, that's the after? Oh, yeah, I got you right. Thank you. Yeah, thank you. 2 kilograms moving at 5 meters per second. So the bx is the momentum, so that's going to be 2 times 5, right? That's the momentum. And then we find the x component of that, so that's 2 times 5 times cos 45. And I am without calculator. .1, we'll say. Now, are positive and negatives important here? The answer is yes. Real important. What's the x component? To the left, and so this is going to be negative. And that negative is not going to come out of the equation. You're going to have to, like, assign it, right? You're going to have to come up with that yourself. Okay? So now afterwards, so ax prime after collision over here, right? The x is going to be opposite sign. And the momentum is A is a mass of 3. And after it, oh, hang on. You didn't stop me. We're trying to find the velocity of mass x, aren't we? In other words, it's a question mark. Don't know it. That's what it says in my notes. You should listen to my notes. Bx prime. This one over here. Okay. Again, the x is opposite. B is a mass of 2. After it is moving at 3.5, so 2 times 3.5 times opposite sine, and the angle is 20. Do you see how there's plenty of room to make not silly mistakes, but like where you put the wrong number in? Right? So you're really going to have to slow down, take your time, make sure you're kind of double checking everything here. 2 times 3 is 7. 7 times the sine of 20. We'll say 2.4. And that's to the right, so it's going to be positive. Okay. What should I do now, do you think? Keeping in mind, we said the initial x is equal to the final x, right? What's the total initial x? These guys. What's the total final x? These guys. So let's just sort of set it all equal to each other, right? So I've got, maybe I'll rewrite this. All right. Pix is equal to Pfx. So Pix is going to be Ax plus Bx is equal to Ax prime plus Bx prime. Does that make sense? Ax, the initial x is the Ax plus the Bx, and the final x is, oh, and here I used final instead of prime. I kind of mix in my notations here. Ax prime plus Bx prime, which are these values here, right? So Ax is 0. Bx is minus 7.1. Ax prime is what we're trying to solve for. Bx prime is plus 2.4. And so when I solve all this, I'm going to get my Ax here is going to stay on the right. The 2.4 is going to go to the other side. So I got minus 7.1 minus 2.4. I can do that in my head. What am I doing? Minus 9.5 is our Ax prime. Does that match what we thought? Ax is moving to the left. Yeah, that matches, right? Okay. Now guess what? We're going to do that all over again for the y. Py is equal to Pfy. And so I need Ay. Ay is straight north 3 times 4. Or 12. Right? 3 times 4. The mass of A is 3. It's moving at 4 meters per second. It's straight north. 3 times 4 is 12. No angle needed. By. Now you can go back to here to make sure your By is 2 times 5. Let's just double check that we did that right. Moving at 2 kilograms, moving at 5, so 2 times 5, and it's north 45 west. So the y is going to be the opposite here, so that's going to be sine 45. It's going to be the opposite of this, right? So 2 times 5 times sine 45. 2 times 5 times the sine of 45, which is 10 times sine 45. And what do you know? 7.1. Hopefully you realize that with 45 in there, right? And is that positive or negative? Positive. Because it's going up, right, Ken? Okay, so now we're going to do the Ay prime. That's the one we're looking for. So question mark. by prime.
Here's prime.
Yeah.
That'll be the next fast and
I'll have to
furious.
add that in there, yeah.
Dom's crew teams up with options, right?
Solves calculus problems.
Exactly.
I would say that that movie would probably be derivative of the others, wouldn't you?
I don't know. I don't watch the TV.
Come on, you missed the joke.
No, I know exactly what you're doing. It's not
Oh.
like a smart studies.
Not the Fast and the Furious, the Smart and the Studious.
Oh, God, yeah.
Are we recording here? Did you get that, Josh?
It's all been covered.
Yeah, thanks. Thanks for coming in.
I think Josh actually watches it.
Oh, what? People don't watch my videos? Thank you, Bill.
Oh,
Thank you. Thank you, Connor.
hope you watch that. He should like really be here. Like, if you see-
Oh yeah, let's move on. By prime. Let's go back and refocus here. So the bx is 2 times 3.5. Let's double check that. It's a mass of 2. It's moving at 3.5, so I'm good. North 20 east. So instead of sine 20 east, it's going to be cos 20. 2 times 3.5. 2 times 3.5 times the cosine of 20, right? Yeah. That's going to be 7 times cos 20. 6.6. And those are all, I'm not going to bother writing them, but those are all momentums. And so the unit for all those is going to be kilogram meters per second. Okay, so now we're going to solve for AY, right? And just as before, we're going to say that AY plus BY, the initial Y momentum, is AY prime plus BY prime. And the AY is 12, and the BY is 7.1, which is a total of 19.1, equal to AY prime, which we don't know, and BY prime is 6.6. And let's just double check these signs. Are they all positive? They should be because they're all moving north, right? Excuse me. How about I do this? Save it. Save a step. Right? Take that to the side. So you get 19.1 minus 6.6. 12.5 is AY prime. Okay. Now what? What am I trying to find here? Let's go back. I'm trying to find the velocity of A after the collision. But before I can do that, I got to find the momentum of A after the collision. So I got to take my AY prime and my AX prime and add them together by vector components. So AX is minus 9.5, so that's going to be left 9.5. And the AY prime is up at 12.5. And this, my friends, is A prime right there. So now I'm going to go A prime. Now be careful here. It's A prime squared, I guess, right? Is equal to 12.5 squared plus 9.5 squared. So A prime is equal to, don't forget the square root, 12.5 squared plus 9.5 squared. And then take the square root of that. 15.7. Does that seem about right? But that is kilogram meters per second, right? And I actually only want the velocity, so how am I going to do that? Well, that's just back to momentum, P equals mv, and so my P is my 15.7, and the mass of A was way up here, 3 times the velocity. So 15.7 divided by 3, and you get, what the heck is that? I'm in like binary here. 15.7. What the? 5.23 meters per second. Oh, and am I done? Caleb says no. Why not? Yeah.
Find
Correction?
the angle.
Yep. Yep. Inverse tan, opposite over adjacent, 12.5 over 9.5. That's tan minus 1. Second function tan, bracket, 12.5 divided by 9.5. 52, we'll say 53. West, 53 north. Now I have to say, marking these takes a long time and a lot of patience. It goes a whole lot easier if A, you show your work, and B, you get it right. So if you wouldn't mind getting it all right, I'd appreciate that. Okay? How many marks do you think for something like that? One. Yeah, multiple choice.
Uh-oh.
Yeah. 1, 2,
Yes.
3, 4, probably 4 halves there, so 5, 6, 7, probably 8, 9. Now, this qualifies as vector addition, right? So remember the deal on the exam, right? If you get this better on the exam, then it goes back and we can adjust. So, but if you get it right on the test, no problem. Okay? So have a look back at your first unit and see how did you do on vector addition, and if you did lousy, well, here's a chance to improve. Can we do one more? Have we got time, do you think? Can you stay with me long enough? Are you awake enough? This one might go a little quicker. I'll pause for a second. This one I'm going to do by vector subtraction because you can sort of do it this way as well. I could have done this one by vector subtraction. I chose to do it that way. Some people prefer to see it that way. I realized actually it was just last semester that these were possible to do in a vector subtraction sort of way. So I'm going to sort of approach this one a little bit different. And I've got my notes here, and I hope I don't go astray because I haven't done it this way much. 2 identical curling stones of mass 19.5 kilograms collide as shown. And do you have a picture? The first stone hits the stationary second stone with a velocity of 5 meters per second north. So again, I've chosen that just to make things a little bit simpler. If the velocity of the first stone is 3.2 meters per second north 30 west after collision, find the velocity of the second stone after the collision, omit friction. Okay, so let's draw a picture. So I've got, we'll call it rock A. It's traveling straight north. And the second stone is like this. It's stationary. If the velocity of the first stone is 3.2 after, so in other words, the A at north 30 west, the A is going to go like this, right? The A is going to hit this rock and go like that. And so which way is the red one going to go? It's going to go that way, right? So after A is traveling like that, and B is traveling like that. Very similar to the last one. Okay, so let's do this by vector subtraction. Okay, let me see if I can pull this off here. I'm going to start with my old friend Pi is equal to Pf. And I mean total initial momentum, right? And that total initial momentum is made up only of the momentum of rock A, right? Because it's the only one that's moving. So I'm just going to say here over on the left, I'm going to say PA. And the final momentum is made up of the rock A and B. And should I use final or should I use prime? Do you guys care? Doesn't matter? You're good? Just change it up. I'll use final here. Okay, so this is going to be PAF plus PBF. And these, by the way, are all vectors. And on purpose, I'm going to put the vector symbol over top. I've kind of ignored that for a while, just to sort of make things simpler. but I want to leave it in there for this one. Okay, so what am I trying to find here? Find the velocity of the second stone, that's the b after collision. So in other words, this is the one here that I'm trying to find, right? Okay, these are vectors. Can I do this by vector subtraction? Absolutely. How do I find PBF? I'm going to take PA and I'm going to subtract PAF, and those are vectors, is equal to PBF. Right? That vector is that vector minus that vector. Vector subtraction. Yeah, that works. I wouldn't mind a few more nods, just to sort of make me feel like I'm going on the right track here. I'm reaching you. Okay. Okay, so and of course I've changed up my notation here. Well, how do we do vector subtraction? I think I'm going to put that away because that's just confusing me. How do we do vector subtraction? We find the components and we subtract them, right? So we're going to find, let's deal with PA. Well, as before, PAX is equal to 0. And you might remember from vector subtraction, it's nice to put them in columns. Put the B over here. P-A-Y, not the B, the Y, sorry. P-A-Y is going to be all the Y, so it's 19.5 times 5. Why didn't I pick 20? That's stupid. That's the mass. 19.5 times the first stone hits the stationary second stone with a velocity of 5. So it's moving at 5. So it's 19.5 times 5. This is out of the textbook, by the way. I didn't pick these. 97.5 kilogram meters per second. I'll just leave the units out just to simplify it. Okay, so now I got to find PAF. PAF. PAFY. Is that right? Yes, PAFY. Oh, those grade 11s, their heads would explode. The momentum of rock A after collision, final, but only the Y component. What is the Y component of A going like this? So A, find the velocity, PAF, velocity of the first stone is 3.2 after collision. So this is these are the ones I'm looking at here, right? So it's mass times velocity. Again, 19.5. The velocity of the first stone after is 3.2. And now my angle, north 30 west. I should probably have a picture here, shouldn't I? I guess I sort of do up here, right? Can I squeeze it in here? Okay, so why did I put a Y there? Why did you let me put a Y there, you guys? Should this be the Y here? This is the X column, right? That should not be a Y. That should be the X. Fortunately, I haven't done the angle yet, so that's okay. Okay, so the X component of this little guy right here is opposite, and the angle is north 30 west, so that's going to be opposite. That's going to be sine 30. I think I did that right. 19.5 times 3.2 times the sine of 31.2. And X, that's to the left, so minus 31.2. What if I can drag this guy over here? Oh, I can't. Good. Okay, so this is down here is going to be PAFY. It's going to be exactly the same as this, just instead of sine 30, it's going to be cos 30, right? 19.5 times 3.2 times cosine 30. $54. Y is up, positive 54. Okay, so I've got my x and y components for each of them. And now, how do you do vector subtraction? You subtract the components, right? So I'm going to take these ones. Can we put a big negative sign there? All right, we're going to subtract them, right? So in other words, I'm going to get, when I subtract, I'm going to get PBF, but over here I'm going to get PBF, the x component. The x component of the final momentum of rock B. It's going to be 0 minus 31.2. Or in other words, positive 31.2. In other words, rock B is going to go to the right at 31.2. Is that what happens? Does rock B go to the right? Sure does. And over here, we're going to have what? PB final y. The y component of the final momentum of rock B. And that's going to be 97.5 subtract 54. 43.5. And now I've got my x and y components of my rock B, and now all I got to do is recombine them back together, right? You know, kind of like when Star Trek, they send the guy or the person, you know, they take them apart, components, and put them back together at the other side. No Star Trek people in here? No, Martin disagrees. It's nothing like that. No, you just never seen that before. It is. Well, I'm just talking about how they take them apart and then put them back together again. Put somewhere else. Yeah. Well, somewhere down the page. So x is, I'm going to draw a picture. X is 31.2. Y is 43.5. This is PBF. So PBF squared, that's why I like that without the prime, I guess. 43.5 squared plus 31.2 squared. PBF equals 43.5 squared plus 31.2 squared equals square root 53.5. And again, that's just what? That is kilogram meters per second, right, Connor? So we actually want to, I'm sure we do, right? We want to find the velocity of the second stone. So P equals mv. This is the easy part. Once you get to here, it's a breeze, right? It's kind of like the last 2 or 3 minutes on the elliptical program. It's kind of, you know, the cool down portion. Am I wrong? This part here, Martin? Okay, I'll try it again. 31.2 squared. No? Okay. It happens. 53.5. Yeah, I'm good. The mass of the second stone, they're both 19.5, I think, right? So the velocity is at 53.5 divided by 19.5, 2.7 meters per second. And as before, you got to get the angle. Tan minus 1, opposite over adjacent. Opposite is 43.5. Adjacent is 31.2. Second function, tan, bracket, 43.5 divided by 31.2. 54 degrees. That's going to be east, right? East. 54 north. I'll pause for a moment. And now I'm going to ask you, which one of those ways do you think makes more sense to you? And I'm guessing that some of you will like the first way and some of you like the second way.
First way.
You like the first way? Because I did it first?
So you don't have to have like 4 letters.
Fair enough. Say again, Bailey? Okay. You know what? For all the years I taught this, I never even thought about a vector subtraction, and the kid said to me last semester, could we do this by vector subtraction? I was like, oh yeah, I guess you could, right? And so I do it now because if you've struggled with vector subtraction, it's another way for you to, another opportunity to practice that, I guess, right? Another way to think of it. Okay? So again, that would likely be, actually, if you look at this, it's actually less,
It's less actual.
I think it's less actual work, is it not? Right? Yeah. It's less actual work. So let's just sort of summarize here. I know we're running out of time here, right? So basically, I set up my vectors, and then I went by vector subtraction, and then I just do a straightforward vector subtraction question. In the previous one, I sort of broke it into x components and said they're equal to each other, right? And then I did all the x, and then I did all the y. And you know what? If I wrote a little smaller, a little more condensed here, this may be about the same. Like this part is all the same, right? This is really just the vector subtraction part, really, right? Right there. And then this is the breaking into components, right? Is there lots of opportunities to make mistakes?
Yeah.
Yeah, there is, right? So hang in there. Like, I'm not going to say expect to make a mistake, but don't fear the mistake, right? There's a good chance you're going to make a mathematical mistake. You're going to drop a negative sign, or you're going to forget to square, or something like that happens. Okay, it happens. Show your work. Literally, the first thing I do is I look at the answer, and if it's right, 9 out of 9. If you get that far and you get the right answer, 9 out of 9. Okay? And I'm serious when I say it's easy to mark if it's right. If it's not right, then what do I have to do? I got to go through all the steps. Right? Okay, but the first thing I do is I look. Okay, is this going to be worth my while? Right? So I look. Well, have they got the angle? Yeah. Have they got this? Yeah. So these are the easy marks, right? Have they shown me vector subtraction? Yeah, there is. Do their components look like they kind of know what they're doing? Yeah. Okay. So then I usually start. Okay, let's start marking components. They got this right. They got this right. Quite often, the common mistake is forget to drop the negative sign. Then I go and look. Okay, have they done the steps? I'm not going to do the math. There's too much to do. Have they showed the steps? Have they showed all the steps all the way through? And if they have, I'm going to trust that your answer is right based on your one little mistake. You drop this negative sign right here. Out of 9, what should you get, do you think? 8.5 out of 9. Okay? So don't fear the mistake. If you think you made a mistake, keep going. Show me your work.